So again, so we are talking about the resources, and we're starting with Summit. Summit is a flagship machine at Aurora at Oak Ridge, and is an IBM machine with 4,608 nodes and performance of 200 petaflops. So on the node level, its architecture is heterogeneous with 2 IBM Power 9 CPUs paired with 6 NVIDIA Volta GPUs. This results to performance of 42 teraflop per node, and obviously very powerful nodes. And they also memory rich. We have 512 gigabytes per node plus the 96 extra gigabytes on the GPU side. And additionally, there's a non-volatile memory per node, which amounts to 1.6 terabytes. So the total machine memory is more than 10 petabytes. So the CPUs and GPUs are connected through the NVLink 2.0, and the nodes are connected through Mellanox dual rail infinite band interconnect. The topology is a non-blocking FAT3. And for the storage, we have our GPFS file system. The size of the system is 250 petabytes. And of course, you can read more details if you just follow the link on the bottom of that slide to the Summit user guides. Okay, the next slide. Yeah, talking about the software components installed in Summit. Summit now has mature and diverse software installed. So we obviously that is just a snapshot. So if you don't see something your particular application depend on, you should reach out to us. Most likely we'll accommodate your request. So that is just an illustration what is on the machine right now. So obviously we have compilers from IBM, from NVIDIA, it's PGI, and we have also LVM and GNU, and we have a bunch of libraries which could help you with your math-heavy part of your applications. It's IBM ESSL, and fast Fourier transform, a Scala pack, and different level BLAS, and also NVIDIA proprietary libraries like QFT, QSparse, and so on. So for the debugging, we have a parallel debugger from Alinea DTT. We also have IBM Parallel Environment Runtime Edition. We have CUDA GDB, CUDA memcheck, and a bunch of other tools like Valgrind, memcheck, StackTrace, so on. For the profiling, we have IBM Parallel Environment Development Edition, and we also have Vampire Tau, and obviously NVProf and HPC Toolkit and other popular tools. So if you're looking a little bit forward, you would like to exercise Keep and Rock'em if you are trying to get ready for the AMD architecture, which is coming. And also if your project has some machine learning, we have a bunch of workflows, like popular workflows like TensorFlow, PyTorch, Python libraries, so NVIDIA Rapids, Watson, so libraries from NVIDIA, from IBM, so on. We have also tools for visualization and also for the workflows. So that's all available. But again, you can read the details following that link. And if you have something you don't see here, or you couldn't find in the Summit user guide, you just reach out to us. All right, next slide. So Frontier is coming up. It's our exascale machine. It's going to have peak performance of more than 1.5 exaflop, and it's an HP Cray supercomputer with AMD architecture. So the same as Summit, Frontier is going to have heterogeneous nodes. They will consist of AMD EPYC CPU connected with 4 purpose-built AMD Radeon Instinct GPUs. CPU and GPU will talk through the AMD Infinite Fabric, and the system level nodes are connecting through Slingshot Dragonfly network. And the I/O capacity will be 2 to 4 times of Summit. And well, this is all approximate numbers, obviously. So please bear in mind that Frontier is still under NDA and we cannot reveal all the details. So with that, I think we will now turn to Marta, and she will talk about the resources available at ALCF side.
Thanks, Dima. One of the production resources available to 2022 INCITE projects at the ALCF is Theta, an 11 petaflop Intel Cray system consisting of 4,392 nodes with second generation Intel Xeon Phi processor, codenamed Nice Landy, or you probably heard KNL. The mission for Theta since day one has been to facilitate the transition to the upcoming Aurora machine and enable workflows at large scale, such as those involved in data and learning methods, as we were discussing before. Each node on Theta has 64 cores and a memory hierarchy consisting of 60 gigabytes of high bandwidth memory, which is MCD RAM, 192 gigabytes of DDR4, and in addition, 128 gigas of SSD, solid-state drives, which can be particularly helpful for data-centric workflows. You can have a maximum of 256 hardware threads per node. And Theta's network is going to be is a Cray Aries high-speed interconnect in Dragonfly topology. You have also, as Catherine was mentioning, initially 2 new file systems that are currently mounted to Theta, it's Grand and Eagle, each one with 100 petabytes. And in addition, projects will have also access to an x86 system named Cooley to facilitate analysis and visualization of science runs for Theta. And also you have access to HPSS tape archive. Next, please. The Cray programming environment is available to users on Theta, in addition to a number of other software, tools, and libraries that you can see listed here. Standard distributed and shared programming models are available, including MPI and OpenMP. Several C, C++, and Fortran compilers also are provided, as well as optimized libraries and debugging and performance analysis tools that you have some of them listed here. Additionally, several software options are available for those projects with needs in the area of data science, machine, and deep learning and workflows. It may be the case of some of the PAs in the audience today. And many of them are currently provided as modules that have been optimized on Theta. So for example, if your project workflow requires a specialized computing environment, Singularity may be helpful as a continuous solution to load your software image onto Theta's compute node. Or for complex workflows involving large campaigns of jobs to be run with interdependencies, Balsam might be a solution for you to consider if you are thinking of ensemble jobs. We highly encourage projects, particularly in the data science and AI variety, to check if your required software is currently available on the ALCF resources and to reach out to us if it's not clear. And we have additional information in most of the machines, a link to the website, but feel free to reach to us if you have questions. Next, please. As we were mentioning, Polaris is a new system that will be deployed by ALCF as one of the INCITE resources for next year. And it will be deployed during the summer of 2021 timeframe. And it's going to be a hybrid CPU and GPU machine. Unfortunately, we cannot provide more details than that, but it will be available for INCITE, as we were mentioning before, as day one. The anticipated Polaris configuration is for a system with peak performance of between 35 and 45 petaflops and total system memory greater than 250 terabytes with DDR and HBM type of memory too. And the node performance should be greater than 70 teraflops with compute nodes composed of 1 CPU and 4 GPUs, the same ratio that you have, for example, in Frontier. The system will have more than about 500 nodes, and we have 200 gigas of node-to-node interconnect. Next, please. The programming models that we have available, as will be presented in Polaris, is, for example, OpenMP 4.5 and 5, SQL, Cocos, Raya, and HIP. You may be thinking of those as one of the options for your project. And you will find also several performance and debugging tools that are available, like obviously GPU tools. This is a GPU system, and you will have also PAPI, Counter, Tau, HPC Toolkit, and DDT for the debuggers. And regarding frameworks, we expect to have Python, Numba, TensorFlow, and PyTorch. But additional information, obviously, will be available during summer and in the second part of the year. Next, please. Thank you. So coming soon to the ALCF is Aurora, an exascale architecture designed for simulation, data, and learning. A sustained double precision performance of more than 1 exaflop will be delivered by compute nodes, each having 2 Intel Xeon CPUs and 6 Xe Intel GPUs, all with unified shared memory. So similar to Frontier, Aurora's network will be the new HPE's Slingshot fabric in also Dragonfly topology with multiple connections on each node. And DEOS will be a key component on Aurora, delivering performance I/O for data-intensive workloads. If your application or your code requires important I/O demands, I will encourage you to start looking about DEOS. We have some presentation that we can point you, or just feel free to contact us. In any case, Aurora will have more than 9,000 compute nodes with a node performance of 130 teraflops. Next, please. The Aurora software stack that will consist on HP Cray Xe software stack, Intel software, and a number of data and learning frameworks that have been optimized for the Intel hardware. So additionally, we have several programming models, performance portable abstractions that will be supported. Most of them are listed in this slide. Please check the website. We have at the bottom of the page, aurora.alcf.gov, that will always display the latest information on Aurora as it becomes publicly available. And obviously, please do reach out to us if you need assistance with the estimation of the allocation on either upcoming exascale systems. Next, please. Now we are starting the section of the presentation that talks about tips for the proposal. So what are the key questions that you can ask yourself in order to prepare a good proposal? So when considering whether your project is appropriate for the INCITE program, we have tried to summarize in this slide some of the key components and the key questions. So for example, is both the scale of the production runs and time demands of the problem of a LCF scale? So if the work you are proposing could easily be completed on a small scale computing resource, then the INCITE program may not be the right choice. However, if your resource allocation needs are substantially larger than available anywhere else, and your science runs are too large to run on another system, then the INCITE program might be a good fit. Another question to consider is whether there is unique architectural or infrastructural resources that your work requires that are not available anywhere else. So this is also another element that some of the projects are asking. So in addition to large scale compute capabilities that are provided in the LCFs, maybe very large memory or I/O performance demands may also be indicators of an INCITE appropriateness. That could be an important element to consider too. So it is important to articulate in the proposal whether the team is also in place. Obviously, we provide the computational resources and the team that is behind. You have to make sure that you also have a team in place, and we'll have to explain that during one of the elements of the proposal that is required. And you have to make sure that they can successfully carry out the proposed science campaign. Next, please. Additional questions can be, does your project have large data and AI needs? We have been discussing this in the slides before. We accept, and there are a lot of applications that are related over the years with data and AI needs. So how is the strategy for your workflow? How are you going to move the data? How is your data management? How are you post-processing? Is everything clearly identified? So with regards to the ensemble workflows, an important question to consider is how individual runs are coordinated. So if you have an ensemble that is run under the direction of a workflow manager with a scalable I/O on a parallel file system, that's perfect. Then the ensemble is really appropriate with what we consider for NCF resources. But if, on the other hand, the ensemble consists of a large number of independent possible serial batch jobs with not workflow coordination or efficient I/O strategy implemented, then the ensemble may not be appropriate for the LCF resources. Do you have plan in place for staging data in and out? That is also important for the facilities. how you are going to process that data. Are you going to archive it in the facilities? Are you going to move the data? And when appropriate, are you going to share it to the community if that is the case? So providing answers to all these questions is in general especially helpful for those who are the reviewers, the audience that we were mentioning before, the computational scientists and the science panels, for assessing the computational readiness of your project. So if you have questions as the appropriateness of the workflow you are considering for this INCITE call, please do reach out to us. We can help you from the LCF to discuss further. Next, please. Now we will begin discussing the outline of the proposal documents. In particular, we are going to focus on the project narrative, which is in the next set of slides, which comprises the bulk of the INCITE proposals. It's mainly, most of the time, is 15 pages maximum. Next, please. So let's get started. An important thing to remember as you start crafting your proposal is that the INCITE program is very broad in scope. The members of the science panel, Catherine was presented initially some statistics of previous years. So all of them are drawn from national laboratories, universities, and industries from all over the world. And you should not assume that the reviewers are familiar with your specific work through other programs. The same is true for the computational scientists that the leadership computing facilities that are reviewing the computational readiness aspects of your INCITE proposals. That was defined in slide 11, I think, that Catherine was mentioning. So while reviewers do have an appropriate domain expertise, it's best to not assume that those reviewers are familiar with your specific work, all the algorithms that you are using in your science campaigns. So the proposals should be written, therefore, with a general audience computational scientist in mind. And remember that the reviewers on the science panels will be assessing the potential impact of your work versus other submitted proposals in the same panels. So we encourage you to look. We have information in the reviewers' questionnaires that are posted on our INCITE Call for Proposal website, and they provide additional guidance. Next, please. The principal determinant of a successful INCITE proposal is the impact of the work proposed. This really cannot be stressed enough, so it's very, very important. It is critically important also to provide a compelling picture of the impact of your science that is accessible to researchers in your field, as well as those that are outside of your area of expertise. And make sure that you explain the scientific challenges that you are working to overcome. We know that it's not easy what you're trying to accomplish, and their significance and the impact of your work if the computational campaign is successful. This is very important too. It is also important to place the proposed research in the context of competing work in your field, and imperative to justify if your proposal, why do you propose the work that you need today, and why do you need the resources that are provided by the LCFs. Next, please. So keeping a general audience in mind, you better describe your approach to solving the science problem, along with the challenging aspects of the work and any preliminary results. The more details you provide, the better. So it's important to clearly map out how the requested resources will be used for the key simulations that you want to accomplish, with the key objectives that you will have to describe in your statements, and the complete project milestones that will be outlined in the milestone table. So all the elements should get in place, and the provided plan and connecting the resources to calculations in support of milestone should be clearly articulated for each year. Remember that if you are asking for a different several years proposal, you will have to describe for year 1, year 2, and year 3, and also in the milestones table. And to bear in mind that the average INCITE award of time for a single project is equivalent to several million of dollars. Next, please. So when it comes to describing your computational approach, you will have to specify, that's one of the sections of the proposal. So please be sure to provide the basic foundation and the key points pertaining to its formulation. So while the chances are high that the reviewers will be familiar with the relevant codes and methods that probably you are describing in the project, it is best to assume that is not the case. And be sure to show justification that the code that you are planning to use is the correct one for your research plan. And do explain key differences, especially if you plan to use a private modified version of a well-known code, for example. Make sure to check that all the programming languages, the libraries, the tools that are needed for your project are available on the system that you are requesting the allocation on. Especially, well, we don't have yet Polaris and Aurora, but you will have to probably follow the guidelines for those systems and the information that is available on the web. But be sure to list all that is required, and note that in some cases users may need to be able to install software themselves. But in any case, if it's not clear, please feel free to reach out to us, and we can help you determine if what you expect to use is available or not on the systems. Next, please. Regarding data management, we continue with the computational approach, but you still have to also mention what are you going to do with the data. You will have to describe some data management plans, so be sure to describe the project needs, what is for input data, for storage during and after your science runs, and the movement of that data between LCFs and other sites. For example, if you imagine that you're doing your visualization instead of the facility, you are doing outside in your university or in your particular center. So to describe how long the data needs to reside in the project workspace on our parallel file system, as well as the archive, if you're going to use the HPSS, for example, on ALCF, and how those times were determined, if possible. The more information you can share, the better. Be sure also to include a description of long-term plans and any tools or infrastructure that is required to support your data needs. Also, include description of AI, analytics, and visualization, if you can, and the workflows and the software that you require. Next, please. It is important to provide detailed description of your planned computational and data-intensive campaigns for each set of runs. This is important, each one. Whatever is there are exploratory, some of them there may be production runs, other may be post-analysis. So do describe all pertinent details such as the number of runs, that's important, the number of nodes per run, and the wall time, for example, for each batch of the job submission. In addition, do describe all IO-related details if your science campaign is including size and frequency, including size and frequency of the checkpoints, how many are you going to need, and for different kinds. For example, some people are storing data with a single precision or double precision, or can be at different time steps of the simulations. The size of that input, if possible, and this output, and discuss the performance where appropriate, if you have the numbers. For output data generated, discuss which resources will be needed to complete your analysis. And for example, the LCF resources maybe a local workstation, as I mentioned before, in your home institution, or are you going to use one of the data transfer protocols that we provide, for example, Globus, or are you going to use SCP? What are you going to use to move the data if you're going to move it? And please remember that, again, it's in red there. The details are important. We read very carefully and try to understand, especially to know what can be in need, what can we provide that you don't have or maybe was not mentioned that will be valuable for your proposal. And yeah, for the proposal milestones and the milestone table. Next, please.
I hear you, Marta. It's just something happened. My camera went on without me hitting anything, and then it all kind of froze. I'm scared of. There we go. It's unfreezing now. My apologies, everyone.
I was scared that I was out of the connection. Thank you. Code performance overview. So the performance data provided in the proposal should support the required capability scales run. So you have to make that connection between what you need and what the machines can provide, and be relevant to the proposed simulation data and science runs, obviously, that you are describing. So be sure to discuss how efficient the applications make use of specific architectural features, like, for example, the multiple GPUs that they have on Summit, or the hardware threads and vector units on Theta. And it's best to generate application performance data on the resource you are requesting an allocation on. Obviously, we don't have some of the machines, especially if you are asking for 2 or 3 years, but similar size runs in other related resources can also be very useful. So be clear about how many nodes are you using, the number of nodes, MPI ranks, the threads, how many GPUs are used to generate the performance data, and that production style IO was used in the benchmarks. Most of the time you include it, or if you don't include it, just make sure that it's clear that it's not included. And also describe the sources of any performance of scaling deficiencies and how your project plans to address them before the INCITE is awarded or during the project, during the INCITE years that you are granted. Next, please. So this is a representation. So when presenting your performance data, it is best to pick the approach that is most relevant to each type of run in your proposed science campaign. That means that you have several codes. For example, it would be very useful if you can display performance plots for different codes if you are applying, if you require. An example in this slide is the weak and extra scaling performance plot that show on the left and the right figures. And you have on the x-axis, we have the number of nodes, and the time to solution is plotted on the y-axis. So weak and strong scaling performance data for the applications to be used, generated with representative inputs, obviously, and especially production style settings, is the most relevant data to show in your proposal. That means that if you, obviously, you cannot complete your simulation, otherwise you will not be asking your time on INCITE award, but you can try to start a simulation and evaluate and get some strong scaling or weak scaling plots that will be very useful to evaluate your readiness. And for each proposed application, plot the performance metric that is most appropriate for your workload, obviously. And remember that you may have different kind of codes, or you may have different kind of machines or simulations. So be sure to also discuss what are the node level efficiencies and indicate, if you can, which node resources are most important for your project needs. Next, please. If the work you plan to propose, now we are going to do a brief discussion of ensemble policy. It consists of a large collection of independent and loosely coupled calculations, then it can be helpful to discuss the computational intensity of that workflow. So if the size of the ensemble is such that a reasonable time to solution can only be achieved by running on a large scale resource, and the volume of the work is facilitated by a workflow manager, as we have discussed sometimes in the past, then the ensemble you are proposing is likely appropriate for INCITE. However, if the members of an ensemble, as we mentioned, can be effectively carried out on a small scale resource with a reasonable time to solution in another machine, then the ensemble may not be really appropriate for INCITE. So we encourage all projects considering ensemble workloads to reach to the frequently, or to refer to the FAQ, the frequently asked questions that we have on the INCITE Call for Proposals website, in this case number 33, as well as obviously to reach out to us if you want to discuss your project plans. Next, please. And now I'm touching briefly on data and AI applications to make sure that we have enough time for the rest. So just a few words. In addition to the traditional computational intensive simulation projects, remember, we encourage INCITE proposals that support data and AI campaigns. And those proposals in this area should contain obviously strong aspects of scale data process and employ AI methods at the scale of the leadership computing facilities, so the resources that are going to be available. So the examples of capabilities employed by are included here, some of the points, but are certainly obviously not limited to the machine and deep learning intensive computing. So we have some areas, but hopefully this will surely continue to grow as the large scale data and AI capabilities continue to mature. So the INCITE program does indeed receive strong proposals, having significant data and AI components. And these proposals are evaluated, as Catherine was mentioned, in data and AI panel. Next, please. And just a quick note, the recipe for success when it comes to data and AI-centric proposal is really not different from what we have seen in a traditional simulation proposal. So proposals should be clearly articulated. They should present the objective of the planned work and provide details on dependencies with a complete end-to-end research campaign, as the simulation proposals are doing. A full list of applications required should be provided in the proposal. That's important, including, for example, database, learning frameworks, workflow managers, container solutions, or other elements that you may need. And it is best to generate the performance data for your data and AI workflow that demonstrates your software stack that can be run efficiently at a scale. Obviously, if you can and the resources requested, maybe it's a little tight for this submission, but for those who are attending, maybe for the future years. And for this reason, it's especially beneficial to the PIs, considering these data AI-centric proposals, to request discretionary allocations in one of the LCF ahead of time. And when you plan on generating this benchmark data, it's important that it's generated with the representative production science runs, as we mentioned also in a couple of slides before, for all the cases. Good plots, they are gonna save you sometimes. And with that, I will pass it back to Dima.
Thank you, Marta. So we continue with the discussion narrative. Let's have a few words about development work. It is perfectly fine to have a development component in your INCITE proposal. But if you do choose to have such a component, so please describe the work with the focus on connecting your work with the particular milestones. So it's important to identify any dependencies and how you will validate. Also, don't forget to estimate and include additional computational resources required for the development work you're proposing in your INCITE. Okay, next slide. A management plan. So it's a part of the INCITE proposal where experience of the team, credibility of the work proposed, and transparent use of requested time should be reflected. Thus, please list their scientific and technical members, as well as their experience in relation to the proposed scientific or technical goals. So successful teams demonstrate knowledge and efficient use of HPC computing resources in accomplishing scientific and technical goals. So it's important, project involving multiple teams or different thrust areas should clearly state how the allocation will be distributed and managed among those thrusts and areas. So please do include a personal justification as a brief description of the role of each team member. Although it's not a requirement, proposal with application developers or clear connection to development teams are usually favorably viewed by the computational readiness reviewers. Next one. Okay, it's the milestone table. It's an integral part of the INCITE proposal. The milestones should be formulated for each year of the proposed work. Obviously, if you propose multi-year proposal, they should be appropriate for the size and duration of the requested award. Importantly, the performance and future modification in scope will be tracked using those tables. So for each milestone, please provide following details: computing resource and allocation request in node hours, file system and archival storage, and duration of the storage, software application employed, summary of the computational tasks, for example, computational runs, data analysis, post-pre-processing, so on, dependencies on or between other milestones, and expected start, target completion date, and the status. So again, just gently stress one more time, the milestone table is a required document. Proposals without it won't be accepted for the review. And the easiest way would be to use templates, and those are provided from the submission site web page. All right, next one. We'll talk a little bit about publications. Publications are extremely important in scientific community to document scientific work done, but they're also important for the leadership computing centers to show the impact of the INCITE program. And this impact, of course, within the scientific community itself, but also for our users and future users, as well as DOE, our sponsor, and the general public, of course, also. So we ask proposal authors to list the publications resulting from previous INCITE awards. And especially, they should also, of course, relate it to the proposal under consideration. All publications that were enabled by INCITE should include an acknowledgement for the INCITE program. But if you do add publication, please include only publication with INCITE acknowledgements. Okay, we'll proceed now with timeline. So this is a timeline for the INCITE, and it is important to understand that actual dates are always shifting year to year, and so you should always refer to the web page and check this year exact dates. As Karen already mentioned, important date 2 weeks from now, June 18th is our deadline. So please keep that in mind. So this slide illustrates general workflow, and obviously there are 3 main phases: the solicitation and review, selection and awards, and then access and monitoring. So we are obviously currently in the solicitation period, which will last until mid-June, specifically June 18 this year. So it's important to mention the actual dates always change, so do check with the web page. So then right after solicitation, a computational readiness review process starts, which will be followed closely by external scientific panel peer review. The review process is usually done by the end of September, and the selection process starts right after the reviews are done, and usually takes place in October. And during this period, several meetings are held by the selection committee at both leadership centers, and the awards are then announced typically in the beginning of November. And the process of access processing will follow, and the awards will follow the awards announcements, and all the project will start on January 1st, according to the calendar year schedule. Okay, that is our schedule. Now we'll continue. So this slide is meant to help you make a decision. So are you ready to apply now? So if you ask yourself this question, so please consider, first of all, is the code ported before submitting the proposals? If you are going to use community software, check if HPC ready or GPU accelerated or GPU accelerated version available from the developers. If you are the developer of your own software, then request startup account for development and benchmark runs on the resource you are requesting in your INCITE proposal. So second point is the compelling benchmark data gathered. So prove application scalability in your proposal. Run production scale examples relevant to the proposed work. If you cannot show proof of runs at the proposed production scale, then provide a very tight story about how you would succeed. So it's important to stress one more time that the benchmark examples should be as similar as possible to your proposed production runs. In case they are not, so make it very clear why another benchmark examples are also valid. Okay, next slide. So next slide, we'll talk about applying for the startup account, requesting a mean to help you to prepare for the INCITE proposal. So such resources or such channel is our director's discretionary program. And the primary goal of this allocation is porting, tuning, and scaling up codes in preparation for the INCITE submission. So you may request DD, so short for director's discretionary. You can request DD any time during the year, and we actually encourage users to submit DD at least 2 months before INCITE call for proposal closes. So obviously we are probably too late if you are thinking about applying for this year INCITE, but if you plan a little bit in the future, you can apply for a DD right now and be prepared for the next year INCITE. So there are 2 links here on this slide, and those are the links to DD program for the both facilities. They will give you all the details, how to apply and so on. Okay, next slide. Yeah, so this is a summary slide. So the final checklist. So your INCITE proposal should have an executive summary, it's 1 page, and a project narrative, including impact of the work, objectives, benchmarking. So that's the major part of the proposal, 15 pages. So it should also have personal justification and management plan, and milestone table, publications resulting from the INCITE award, and PI, co-PI biographical sketches. So with that, we are done with narrative, and I hope we gave you good overview what is inside narrative, how to write it, and also the hints what is important in writing an INCITE proposal. So with that, we'll get back to Katrin, and she'll have some question answers and final remarks.